If we have a regular looking equation, that's going to be our 100%. We can always use quadratic formula. Okay, so let's write this up at the top. You've got a little bit of space. Quadratic formula. Negative b plus or minus the square root. B squared. Remember, you need to make sure you're putting that in parentheses. Minus 4 times a times c. All over 2 times a. And remember, we talked about a, b, and c, and signs do matter. Okay, so let's review what we did yesterday. So x equals, and again, we're just taking those numbers and putting them in place of the letters. Good morning. So negative b. Well, my b is already negative. So what happens when we have a negative negative? It becomes a positive. So this becomes positive 11 plus or minus the big square root. Gonna put that negative 11 in parentheses. Squared minus 4 times my a is 2. My c is negative 21. All over 2 times 2. Then we said, okay, everything is set up. It looks great. Put everything underneath the square root into either your calculator or into your Desmos, and we're going to get a number there. So we got 289 when we do that. So we're going to go ahead. We need to rewrite everything else. What about 2 times 2? What do we got? 4. Square root of 289. That is actually a perfect square. So use your calculator. You should get what? Plus or minus 17 over 4. Now remember, this is 2 different problems for you, right? This is 11 plus 17, which is 28 over 4. What about 28 over 4? What do we get there? 28 over 4. We get 7. And this is also 11 minus 17. 11 minus 17 is a negative 6. Negative 6 divided by 4 simplifies. You can do it in the calculator, negative 3 over 2. Or you can write it as a decimal. I'm going to actually write it underneath because I don't want to run into the next problem. Negative 1/2. And remember that these are our rocks. If we were to graph this equation in Desmos and we tap where the x-intercepts are, we're going to get a positive 7 and a negative 1.5. On this second one, this is that square root method. We've got this parentheses here, so we need to move everything away from our x. So this 2 is multiplying, so instead we're going to divide. X plus 5 quantity squared. Anyone know 72 divided by 2? Should be 36. And then how do we undo a squared? What is the inverse or the opposite? Yes, the square root. So these are going to cancel. Our parentheses go away. And then what is, be careful here, we talked about this a couple days ago. What is the square root of 36? What times itself is 36? 6 and negative 6. So we can write plus or minus 6. And now, how do we get that x alone? We're going to move that 5. We're going to minus it. And remember, this is, in fact, also 2 problems, right? We have x equals, you can write the 5 first, or you can write it last. It doesn't actually matter. So we can say negative 5 plus 6 and negative 5 minus 6. Well, what's negative 5 plus 6? 1. And what's negative 5 and negative 6? Negative 11. So again, these are our rocks. If you wanted to graph this one to check it, you're going to have to move this 72 over. Because remember, when we graph in the computer, we have to make sure that everything is on the same side. So if I move that 72 over, it becomes a negative. The solution, okay, or the rocks, is the x value that makes the equation true. Now that can be on a quadratic, that can be on a linear, that can be on an exponential, right? You've been plugging your x values into equations to get true on that yellow calculator since middle school. A solution is the same thing as a root, an x-intercept, a 0. Even if we're talking about a linear equation, if it says 0 or x-intercept or root or solution, even though we mostly talk about that with quadratics, it's still the same thing, okay? And that's our little mnemonic device with the rocks, okay? So we are going to continue to look at those, and we're going to do that with graphing, which is by far your favorite thing, okay? The function below is graph. They've already given us the picture. We don't even have to put it in Desmos, which is nice. What are the solutions? What are the rocks? What do you see here? What are the solutions? Huh? -3 and -3, 0, and 1. So a new way I'm going to show you that you can write this. You can write it with these little brackets if you want to say x equals -3, 0, x equal. You can write it as a coordinate as well, but you can see it in different ways, okay? What do we notice about the y values when we write our rocks? Our y values are what? Always 0, okay? Y will always equal 0, and that is why when we write our quadratic equations, right, we need it to be equal to 0. We need all the numbers on the same side because we're saying y is 0, so we're finding those roots. For quadratics, we have 3 types of solutions. We've talked about this before, right? This is crossing the x-axis, so we can have 2 solutions or rocks. Actually, let me write that as rocks because we want to use all those words. How many on this middle one? How many times is it touching the x-axis? 1. Oh, what about this one on the end? This one is none. And we did talk about that, or no solutions, or no rocks. Remember, if we get like a negative square root, it's going to be none, right? It's not crossing that x-axis. Here we go. If they don't give us a graph, we are going to need to put our equation into Desmos. Now, I do want you to remember, we're going to put a little star here. We need all of our numbers on the same side. That is the only way we can graph this. So I need you to go into Desmos right now, type in -x squared plus 23x minus 112. When we come back here, so we can write this lots of ways. We can write it as coordinates. Okay, we can write x equals 7, 16. You just have to put it in those little braces. If you can't draw the braces, you can always make the squiggles. But really, the easiest way to do this is just graph this in Desmos. Okay? And we can do that on this next one too, but what's wrong with the next one? What was this key star that we put up here? All of our numbers need to be on the same side. Are all of our numbers on the same side here? No, I need to move this 50x over. How am I going to move that 50x over? We're going to subtract it. So now we have 16x squared minus 50x plus 25. And we did look at that yesterday with quadratic formula also, right? If they're not all on the same side, we got to move them. And now you can graph that in Desmos. So I'm going to give you a minute to do that. All right, when we graph this, we get x equals 0.625, a little tiny decimal. And is there a second one? What is it? And 2.5. So again, you can write it like this. You could write it as a coordinate. Either way, I will take it. Just make sure you're putting that in Desmos to see it. We did look at this next word problem the other day when we were looking at square root method. We said you cannot do square root method if it's given to you in standard form. Okay, so we would just need to graph this in Desmos, and we're gonna have to look at our roots. So I'm gonna give you a minute to do that. Graph in Desmos and tell me what x equals. Make sure you use x instead of w when you put this in the computer. So this also has two roots. We have -14 and we have 8. Now, I do want you to pay attention. We talked about this before. We're talking about width, and it is in feet. So does it make sense to have -14 feet on a trampoline? Can we have a negative measurement? No. So in this case, our only answer is 8 feet for the width. We could plug that in and then find the length if we needed to. But pay attention to your situation because negative measurements will not make sense here. Last one, another little real life situation. The total number of seats in an auditorium is modeled by 2x squared minus 6x. X is the number of rows. How many rows? So we're looking for x. That's what we're looking for. So we're looking for those rocks in an auditorium if it has 416 seats. Okay, so look, it says total number of seats is this. So we have to pay attention. They're asking us about x. So this right here, this 416 is our y. So, or our f of x, same thing. So if I set this up and I plug my 416 in, what do you notice? Can I graph this? What do I have to do before I can graph this? Yeah, I need to move. I need to subtract this 416 and put all my numbers on the same side because remember, it needs to be equal to 0. Now, you can go into Desmos and graph this. So I'm going to give you a minute to do that. Make sure you graph 416. I forgot to put a number when I transferred it over. I apologize. So when we graph this, we get -13. And remember, this is rows. And we get +16 rows. So I want you to think about when you go to the auditorium here at school or you go to a movie theater, do both of these answers make sense? No. What would be our best answer here? 16. It doesn't make sense to have, again, negative rows. So there will be some word problems on our test that look very similar to this. So you need to make sure you just know what is it asking for, what is the number they're giving you, where are you going to put it, and then changing things around. So here's that first example. And again, the nice thing about Desmos, we can tap, we can see those roots. We don't actually have to do any math. Remember, this is a negative on our x squared, which is why it is opening down. Remember also, just review from previous unit, this is going to be our y-intercept. It's way, way down there at -112. So we can write our roots, our solutions, our x-intercepts, our solutions, all of the things, zeros, 7 and 16.